Many astronomers have recently turned towards exoplanets, which are planets that exist outside our own solar system. Since the beginning of the hunt for exoplanets, astronomers have been looking for more ways to find smaller and smaller planet-star systems in our universe. Astronomers are now using a new technique known as microlensing to detect even smaller planetary systems. Today we are looking at a paper known as OGLE 2017 BLG 1522, a giant planet around a brown dwarf located in the galactic bulge, a collaboration between the OGLE and KMT-net. Using microlensing, astronomers appear to have found a new Jupiter-sized planet orbiting a celestial object called a brown dwarf in the Milky Way galaxy. A brown dwarf is a ball of gas which has not yet reached a heavy enough mass in order to start nuclear fusion. Brown dwarfs are not bright at all, they do not emit any light, and they would not be able to be detected using traditional methods. But using the microlensing technique, astronomers were able to detect disturbances in the light and predict the existence of a planet orbiting this brown dwarf. However, due to the fact that this brown dwarf is so far away from Earth, how can we be sure that this prediction is actually accurate? And this sort of leads to our knowledge question. We base a significant portion of science on instrument-based observation. However, it's necessary to consider the reliability of the observation itself. So to what degree can it be said that instrument-based observation, particularly that which humans can't necessarily see, like astronomy and the detection of exoplanets, is scientifically accurate? And we're going to answer that using the content of the paper. So first, let's talk about a bit of the background of gravitational lensing. Einstein postulated with his theory of general relativity that everything travels in space along curved paths, and the degree of the curved path depends on the magnitude of the gravitational field it's experiencing. This is how orbits work, and that's how the Earth travels along its orbit around the Sun. However, light has also been found to do this in a phenomenon known as gravitational lensing. Now, most of the time we see this in extremely massive objects such as black holes, and then that's where we see the famous Einstein ring formation. This gravitational lensing phenomenon also applies to much lower masses, since light can bend around virtually anything, and it does. So, what astronomers have been doing is they've been using a larger star, a bright star, as a source star, using the star that they're analyzing, or the object that they're analyzing, and its planet in the middle. And when we see the planet and the target star align, we can see changes in brightness depending on how far apart the planet is from the star, and we can also deduce their masses from these observations. And that's how microlensing works to detect planets. The biggest part of this discovery is that this works on very low mass stars. So instead of needing to look for exoplanets only on the largest of stars, which are extremely rare, we can look at what's called M-class dwarf stars, which are much lower mass stars, and these systems are much more common in the universe. So using this method of microlensing, we can possibly detect even more exoplanets. But now let's talk about the experiment itself. So first, we need to get into the funding. This project is funded by what's called the Optical Gravitational Lensing Experiment, a Polish astronomical project hosted at the University of Warsaw. Their goal is to try to discover dark matter using microlensing, and it has started discovering exoplanets as sort of a side thing. So the University of Warsaw is a rather legitimate institution, and it doesn't look like that they have any malicious intentions. But then again, since their primary objective is to look for new celestial bodies, it may be biased towards trying to find a conclusion that leads to discovering more planets. So now let's talk about the experimental methodology. They used a simple telescope that looked at the brown dwarf system and looked for changes in light, and the magnitude alteration allows them to determine how massive the planet is, how far away it is, just based off of the luminosity changes. So it's some pretty amazing stuff that they can get just from this. However, if we take a look at the actual reading graphs, we can see that the error is quite high. However, the mass calculations were done using some fairly reliable equations because they're based off of methodology that were used in other papers in finding more massive exoplanets. So although the study could be said to be mildly inaccurate, the analysis and discussion were really well done, so I'd say that I'm pretty confident about the findings of this paper. So this sort of leads us to the answer to our knowledge question. Of course, we know there's always going to be error in instruments, as seen with the error range in this study. However, as long as we accept that everything we know could be false, it may as well just be right, because this paper was really well conducted and really well analyzed and really well done, even though we might not be completely sure. So for our question, instrument-based observation is pretty accurate. And that's it for this video. Thank you for watching.